This is station 1, drawing wire. So we want to start with our wire, and you need to get a picture of it. We need to get the mass, and we need to get the length. So I have my scale on. Let's go ahead and get the mass. And we need to get the length. We want to make sure we get the length in centimeters. About 10.5 centimeters. Okay, so now we need to see which hole it'll fit through, the smallest hole that it'll fit through on our die. Fits through pretty easily. That was 1.2. Let's see if I can get it through 1.1. Okay, that's 1.2 again. Okay, let's see if I can get it through 1.1. Okay, so 1.2 is the smallest that it'll fit through. Right now, it does not go through the 1.1 hole. So what we're going to do is we're going to take our file and we are going to file the edge until we can get it through a smaller hole. So you want to file along the edge. And this will take quite a bit of time. Let's see what hole this will go through. Ooh, okay. So now this can fit through the 0.9 hole. So this is 2 holes that's skinnier than our initial wire that we had. And the length, 14.7. So this was the one that we started with, and then this is our one that's been stretched out. Okay, so you can see that this one's much longer, and you can tell that this one is skinnier. Okay, so now we're going to do station 2, rolling the penny. So here is our penny. We're going to roll it, and it's going to become much skinnier and thinner, and it's going to become wider in size. And then we're going to be able to stamp that for station 6, make impressions on it. Okay, so let's go ahead and roll the penny. All right, so I need to tighten this machine so that the penny goes through, but with some resistance. So there's these 2 rollers here, and they're too far apart right now, so the penny goes through without any issue. So I'm going to tighten the crank here, give it a quarter turn, and see if it catches, and it still went through with no resistance, so I need to tighten it a little bit more. So do another quarter turn, and there's a little bit of resistance there, but really not much. So we're going to do another quarter turn, and that should be good. This one should be really, this one should be more difficult to get it through. Okay. It's just a little bit flatter there. If I go like that, you see the reflection. It's gotten a little bit flatter. Okay, and you see around the rim especially. All right, so we're going to zoom back out, and we're going to tighten the crank a little bit, and we're going to go again, and we're going to make it even flatter. So quarter turn, and feed it through. Now, the first time you crank it after you tighten the rollers, it's going to be more difficult to get the penny through because you've just tightened it. So we're going to run that through a few more times at this setting before we tighten it again. There we go. It's a little bit wavy, but it's very flat. So those impressions that are on the penny are very flat. You can barely see the impression now where Abe Lincoln's head is. So we are definitely getting there. So keep going. We're going to tighten it again and go again. There we go. You can see we are definitely stretching our penny out. All right. So here we go. Tighten it again. You can still see the penny on that side a little bit. So there's our penny now. You can see it on that side. You see that what used to be the penny. And lead is very heavy. It has a really high density. And I want you to take a look at how it looks before we melt it down. It kind of looks dull, gray. It's not super shiny like a lot of metals. We've got like these little pellets of it. Okay, so I'm gonna put some on the scale here. We're gonna measure out a little bit. I know in there it says like, what, 60 grams and 75 grams because I didn't change it in 2 places. But we're gonna measure out a little bit more than that since we're doing a demo. We're gonna measure out like maybe a little over 100 grams. We'll look at it, what it looks like, and it is. You can see that the hot pot is heating up. Like, look at that bright red underneath. You see that down in there? So it's hot, it's heating up. So we're gonna go ahead and put our lead into the hot pot. Okay. Now we have to just wait for it to melt. While we're waiting for it to melt, you can go ahead and fill in that observation box. And then at the bottom, you need to look up the melting point of lead. That powder stuff, the orange stuff. So that stuff is what we call slag. And so remember how the lead was like dull and gray? So the slag is like kind of where the lead has rusted. So you know how iron turns rusty and it gets like brittle and orange and brownish? So it's reacting with the oxygen in the air. So lead does the same thing, and that's why the outside of the lead was all dull, and that's because the outside of the lead has reacted with the oxygen in the air. So that's called where it's oxidized. So it's like tarnished, it's rusted a little bit. And so that part of the lead, the outside layer that's reacting with the oxygen, doesn't melt. And so it looks like that. So it kind of like, it'll sit on top of the molten lead and look like that. Okay. So we're going to melt it, and then we're going to pour it in this mold. And this mold is a mold of like fishing sinkers. So if you ever go fishing, maybe you've used these before, like a sinker. But we're going to make some sinkers with some molten lead. So it's going to be very hot, obviously, because it's molten metal. But when I pour it, I have to pour it kind of quickly because it'll solidify very quickly. And that's because metals, we said that metals are good conductors of heat. And that means that they heat up quickly, but they also cool down quickly. Okay, so when I pour it in here, if I don't pour it quick enough, I'll kind of walk around and show you what it looks like if I don't pour it quick enough. Okay, it's still going. So if I don't pour it quick enough, I kind of get like these wrinkles in the sinker. Okay, and also, did you see how shiny this is? That's super shiny compared to the dull stuff we were just looking at. Like I said, that's because the oxidized stuff doesn't melt. And so when we pour this, we're just pouring the pure lead, not the rusty stuff. So it's pretty cool. Ooh, now we're getting melty. All right, let me show you what this looks like. All right. Isn't that cool? So that is molten lead. All right, so now we're gonna go ahead and pour that into the mold. All right, here we go. Whoa, got it all over the place. That was not a good pour. I have done much better. I overfilled. I didn't have a very steady hand. This is the next station, I think. Station 4. Melting zinc. Yep. So the penny used to be all copper, but in 1982 they changed it, and now it's just copper plated, which means that there's just a very thin bit of copper on the outside. You can see that. I'm filing the edge of the penny. Oh, it's not.
Yeah, I can see the shiny.
Can you see that it's kind of silvery?
Yeah.
Okay. Let me see if I can.
Fingernails look silvery.
Oh yeah. Oh, there we go. So you see that when I file the copper away, that the inside is silvery, and that's because it's zinc on the inside. Why do you think that they would change it from all copper to mostly zinc? Just copper on the outside. It's cheaper, yes. There we go. So you can see I filed the edge, and it's silvery on the edge now. I have my penny. Let me take a picture of it. All right, we're gonna turn our Bunsen burner on. All right, can you see the flame?
Yeah.
Do you see how there's like an outer flame and an inner flame?
Yeah. One that's like, yeah, and the inner flame's more visible than the outer one?
Yes, and the inner flame's like a lighter blue. So the light blue cone that's on the inside is the hottest part of the flame. This is the very top of that cone.
I see this is orange.
Yep, that's true. So the inner blue flame, the very top of that cone, is the hottest part of the flame, and that's where I want to hold the penny so that I can melt the zinc. Because even though the zinc's melting point is lower than copper, it's still pretty high, right? So I'm going to hold it there, and we're going to watch what happens as the zinc melts to the penny. I'm going to try to get it in focus for you guys. It does take a minute. You can see I'm holding it right at the top of that inner blue.
Will it set the penny on fire?
Nope, it's not going to catch fire, just the inside's going to melt. Because zinc has a lower melting point than copper does. Okay, so the edges are starting to curl, the inside's getting shiny.
What's all that hammering sound?
Okay.
Wow.
So there you have it. That's the zinc. The zinc melted, but you can see that the copper penny, the copper did not melt.
Wow.
It kind of deformed a little bit, didn't it?
Yeah, it looks utterly destroyed.
Yes, it is. Well, and the reason it looks a little deformed, even though it didn't melt, is because it's a very thin foil of copper on the outside of the penny. It's just copper plated. So the new pennies, and this happened in 1982. So any penny that's after 1982 is actually 97.5% zinc and only 2.5% made of copper, and that's because it's just a very thin amount on the outside. And so when you remove the inner layer of zinc, the new outer layer becomes very flimsy. Very, very flimsy. And so now it doesn't look very nice. Okay? We should be able to collect our pieces of zinc and put them on the scale and get the mass of that with the remaining part of the penny. And hopefully we should see that our mass didn't change if I can get all the pieces. I got a couple little pieces over here that didn't. Okay, and so what was our mass before?
2.5.
Look at that. So for this station, I have my penny, I've got my stamps, and I got a hammer, and I got a folder. The folder is to protect the table. All right, I'm going to spell out Go Jags. All right, now when you're stamping, you want to do a test stamp on the folder to make sure that you are holding the letter the correct way. So Go Jags, we're going to start with the G. Also, my penny is slightly curled, so I'll just give it a little tap to try and even it out. So there's the G. Oops. So you can see the G there. And it's reversed because you're going to be stamping it. So you're inverting the image, so it needs to be reversed. So, Go Jags, G-O-J-A-G-S. It's 6 letters, so I don't need a ton of space. So I'm going to start a little bit over. You want to give it 3 or 4 good whacks with the hammer. Alright, and there you can see. There we go. It says Go Jags.